All right, what's up, everybody? We're live again. Today we're going to talk about troubleshooting. So, we're kind of continuing off the build we did last week. Last 2 weeks we've been talking about doing your build, designing your build. And I know it was fairly generic for a lot of you guys, but we're trying to talk for everybody, not just the individual build that you might be designing, right? So we're talking diesels, we're talking drift cars, we're talking circuit cars, everything. But today I want to talk about when shit goes wrong, because if you've ever done any form of racing, everyone knows that your car will run perfectly all the way until you get to the track, and then it will just go wrong. So with that, I'll kick it over to Juan to say his good mornings and such.
Hey, what's going on, guys? Sorry I missed you guys last week, man. Had quite a bit going on, but we are here. We're back. We're live, and I look forward to jumping in on this topic. I know I kind of been out of the loop a little bit, but hopefully catch up and be able to give some feedback. So appreciate you guys having me back. And Adrian's also here. I'm not sure if Cody or Corey's going to be able to jump on today.
Yeah, so Adrian just moved into a new house, I think.
Yeah, I actually just got done. I'm sorry, I'm late. I literally just put this computer together in this new computer chair.
Nice. So yeah, troubleshooting, guys.
It says GT Racing on it. Look at that.
Oh, so fast. So fast. Your mic is so echoey. So troubleshooting, right? I know Adrian's done a ton of it. I'm pretty sure Juan's done a ton of it when I can't get over the fact that Juan's background eats him all the time. Juan's done a bunch of it when he's breaking his motor mounts on his Subaru because he hit a cone again. I obviously did a ton of it and live streamed it out of the last Drift Matsuri when the Skyline did Skyline things non-fucking stop. I hate Nissans so much. So how do we troubleshoot, right? And what kind of makes the difference between professional and an amateur and the guy that does it cheaper, right? I'm going to pull a picture up here a little bit later about the guy that does it cheaper. So for those that don't know, I've been our R33 drift car completely gutted. The rear subframe's out, the OEM gas tank's out, all the wiring is out, and we're starting over from scratch, right? And one of the things that you have to troubleshoot is a system, and that's probably the biggest thing between pros and your everyday amateur, right? Is a system. And I just went through this, Adrian, who doesn't listen to me ever, but when you look at something, especially electrical, right? Electrical, you need to understand the systems. With an engine, you need to understand the systems. That's kind of what defines a tuner, right? Is that we understand the systems that we're working on. So we know how Operation A gets to Operation B, gets to Operation C. So in the case of Adrian, I'm going to let him talk about it a little bit. It was his air conditioning with a link ECU. But the input status, the drive high or drive low, if you will, of that DPI or that DPO, SPI, whatever you want to call it based off the individual brand of ECU, wasn't changing status. And so we sent a lot of questions to Adrian, and it ended up being the first thing that we talked about after he finally got around to testing it, not needing an oscilloscope. So I'm going to kick it over to Adrian a little bit to just talk through that, because apparently it's a really common issue on the JZX 100 with Link.
Yeah, so I finally got around to putting AC back in the car. 6 months ago when I got it, it didn't have the condenser hooked up, and we kind of did some digging, found that we could do a GS300 condenser in the front with an IS300 high side line, and then we just have to extend the wiring for the pressure sensor for everything to work properly. So cool, we do that, get it vacuumed up, charged up, everything's good on that end, and we go to troubleshoot it and see, hey, or not even start the troubleshooting. We just go to do a system check and hit the AC button on the dash, see if it'll turn on. There's nothing at the shop that's doing the AC recharge. We jump the relay, turns on, it's blowing ice cold. AC in the race car is great after 6 months without it. And in Florida, the heat index is like triple digits right now. So happy with that. Well, get back to the house and start doing some digging. You start with the easy stuff first. So I check the pressure switch. We bridge that. Everything's good at the pressure switch side. And then we go over to the computer to see if it's sending the AC request over on that pin, and it's not. So I do a rewind, and I go through the Link ECU manual that comes with the product, and they basically have some weird configuration where an unused CAN port on the board transmits data to the dashboard in the car. And we did a reset on that, and that didn't work. So I noticed that when I did a continuity check on that pin that goes from the climate control unit to the ECU as the AC request, it would turn on. I also opened up the digital input menu and selected that pin, and we tried to change some settings. And after the right combination, it would kick on, but it would stay on permanently. So that's kind of where I ran out of time, because I literally just bought a house. But Seth's right. They were like, hey, put a toggle switch in line with the AC request pin and ground it out to the chassis. So we did that. Like 2 days after they had mentioned it, and boom, AC is working. And in true race car fashion, it's off a toggle switch for now until I get a new climate control unit. But I think what's important, and I mean, I'm going to admit it because I'm not a tuner, I know the bare essentials to get a car running with these standalone ECUs and try to like get in there and just read some things. But, understanding what the menus and what the terminology is, like, I'm looking at it right now. Let me see if I can share this. So this right here is basically what I'm looking at when I open the Link computer, and changing the AC request source to digital input 1, turning the pull-up resistor on, and then putting both active states on high, turn the AC on, which was great as like a short-term request to get it going to check the system. But like I said, I'm not afraid to admit, I have no idea at the time what a pull-up resistor was, what the active states meant, input latch, stuff like that. So
right. So let's go through that. So the output, right, is the wire that it's sending out. So basically you're saying, all right, on digital input, it looks like digital input 6, right? So digital input being a square waveform. So it's not analog. An analog voltage input or an AVI is going to be a sine wave, anywhere between 0 and however many volts that the circuit board is designed to fucking handle, right? So on like the Haltech PD16, PDM, the AVIs are between negative fucking 15 volts, which I don't even know how you get a negative voltage, reverse sine wave, I guess, and then plus 30 volts, right?
So good question. Is this platform, this tuner, because I'm not a tuner either, but this particular software is married to what, Link or Haltech?
Link.
So we're linking to Link ECU right now.
Okay.
G4X from what I can see off to the side right there. All right, so you have a digital input, right? And a digital input is going to be a switch or a Hall effect sensor. It could be a signal wave like a speedo that's been sent through a dash and been put through a conditioner. But basically it's zeros and ones. Think of it like binary, right? It's either on or it's off. It's not, there's no state in between. So that's what we mean by square wave. It's either driven high or it's driven low, right? So it makes sense to everyone. So 5 volts or 0 volts, as an example. So the AC request source on the fourth line there, the AC request source is the input that Adrian is saying. When this input switch or this wire going into the link ECU is turned on or turned off, that is the demand signal for my aircon clutch to work, right? And then it's going out on auxiliary 3 to actually drive the clutch. The pull-up resistor, so the pull-up resistor is usually a 100 ohm or a 1K resistor that oftentimes is built into the circuit boards for these ECUs on certain inputs. It may not be. You may need to add a pull-up resistor, which is just bringing a resistor across a 12-volt circuit back onto the wire, right, and adding the resistance into it. And basically what this will do is it'll take minimal change in a voltage, add the resistance, which will drive the voltage up, right? So the ECU gets a more clear signal is the simplest way to put this. And then digital input 6 latch. So latching, right, would be for a like momentary push switch. If you think of a race car that's had the ignition key put away, taken out, right, you may have a CAN bus signal where you push the button one time to turn the ECU on, and then it stays on, right? So it latches once you push that button. If you don't have latching turned on, it's going to stay on while you hold the button and it'll turn off, right?
Okay, so the latch just allows you to have have a static button as opposed to just a momentary button.
So the latch basically turns the momentary button into a static switch.
Gotcha.
Now, what's cool about that is when you start getting into race cars and you start dealing with like PDMs, for example, you can actually have the ECR or the CCS or your EFI relay, all the same thing, all different names depending on your platform, right? You can actually have that latch through a set of conditions, and then you can use your standalone ECU as like a turbo timer. On the M-Tron, for example, in my RX-7, we have the ignition wire switching to ground instead of 12 volt to the PDM. That powers the PDM. The PDM then sends a CAN signal over to the M-Tron ECU via the Motec system to turn the ECU on, which supplies power to the keypads, which allows us to turn the fuel pumps and ignition and everything on, right? So it all wakes each other. And what's cool is because the ECU is now in control of that relay signal to the power distribution modules, it will stay latched until the ECU finishes data logging or the coolant temperature comes back down to coolant temp targets with my electric water pump, things like that. So the car can manage itself. Even if you take the key out and walk away, the car will manage itself until certain parameters are met, and then it will unlatch the EFI relay or the PDM in that case. So active state, high and low. I missed that one, sorry. DI6, active state, high and low. And this is what we got to with Adrian when we were troubleshooting, is when you push the button, does the status change, right? That's your first clue. If you push a button in a car that's wired to a standalone and the status does not change, either the switch is broken, which is what happened in Adrian's case, right? Or you look at the raw runtime values, and the raw runtime values will show you if there's any change on that voltage signal at all, right? And that's what we're looking for. So you go from 0 volts to 5 volts, for example, right? Or let's say a brake light input into a PDM wired to 12 volts. When you push the brakes, the circuit closes, sends 12 volts to the PDM takes that as an input, and then the input sends out the closed circuit to the brake pedal, or the brake lights rather. Does that make sense? So when Adrian looked at the raw values, there was no change. And that's what we're getting to with troubleshooting, is have a process, right? If you have a standalone, then you have access to all of this data. You just need to learn to use it. And it saves you fucking infinite amounts of time versus sitting there with an oscilloscope or a multimeter and looking at waveforms or working at voltage outputs individually. And a lot of times, unless you have something like a picoscope, which is an oscilloscope that goes to your laptop, you're not going to see these finite changes anyway on a multimeter. It's just not designed for the input speeds. So with drive high or drive low, essentially what you're saying is on this digital input, when I push the button, it is always at 12 volts or 5 volts, right? So the off state is always seeing voltage. And when I push the button, it switches to ground and then goes to 0. So it changes voltage and therefore it changes its status, if that makes sense. You can flip that, so you can set, active state low, and then it's like, okay, I should turn this circuit on if I see ground, and I should turn the circuit off when I see power. So you're able to control those circuits, which on your fuel pump, by the way, everyone, is a really good way to set your static fuel pressure. Switch the input from high to low or low to high, and it's going to turn your fuel pump on without the car running, right? So then you can just let your fuel pump cycle fuel, go set your static fuel pressure without having to pull vacuum lines and everything else, because there is no vacuum, the engine's off, and you're fucking done. Go back, switch it back, start the car, and you're done. You're on your way, and bye.
Yeah, and I still stand by what I said. Having a standalone is a great thing when it comes to troubleshooting. But like in my case, I'm more familiar with Haltech because thanks to Seth, that's what I used while we were in Japan, and kind of I went through my own issues on that platform and just learned it. This is my first time looking at Link, so it pays quite well to learn the terminology and the software, the screens, and what everything means when you're looking at it. So as far as it being amateur hour, like, hey, I get it. I didn't fully understand it, and thanks to the help from these guys, I figured it out. And you're going to have people like that in your local community that, hey, somebody has messed with Link ECU, somebody has not messed with Haltech or HP tuners or Holly, just to get you going.
Yeah,
and I mean, I get the HP tuners thing, but
not from these guys, from Seth, because he's the freaking guru.
Yeah, but down here, I mean, 90% of the tuning is done on HP tuners. I mean, Cody can probably attest to that. So
carbs, baby, carbs.
Yeah, so there's a couple great points that Adrian just brought up, right? One is every ECU does the same thing. Like at the end of the day, every ECU does the same thing. You have digital inputs, you have analog voltage inputs, you have digital pulsed outputs, right? You have fucking your power circuits, your fuel injector circuits, your ignition circuits, right? Where it's going to control that for EFI. They all do the same thing, but they all call it something slightly different. And that's where the confusion starts coming in. And that's why when you go to a tuner, and you hear this across the board so many times, like, hey, pick your tuner, right? Or you'll hear someone be like, well, what ECU should I go with? Well, bro, at the end of the day, like, are there certain ECUs that are better? Like, yeah, in my opinion, there's certain ECUs that are better. There's a reason Motec costs $4,000. There's a reason Mtron costs $4,000 or $5,000. And its capabilities inside the ECU, right? That a lot of you honestly just aren't going to use on the street. You know, like torque management through throttle body mass flow, for example, right? That's something I can do in the Mtron is I can put torque on demand by percentage of the car's output. No one needs that on a day-to-day basis. They need that at World Time Attack. But when you go and they say, hey, ask your tuner what he likes to use, it's because he's familiar with the software. He's familiar with where to find everything on the menus, right? So the tune is going to go faster. You're going to pay for less dyno time. That's why they say, hey, what does your tuner like to tune with? Because, yeah, man, as a tuner, I can tune anything. I mean, Power FC, Mtron, Motec, fucking ECU Master, HP tuners, Cobb, Haltech, obviously, Link. I've tuned all of it. But when someone comes and puts an HP tuner in front of me for the first time in 7 years, it's going to take Seth a hot minute to start digging through menus to figure out what I want. And it's so frustrating as a tuner because when I have the car on the dyno, I can hear what's wrong with the car. I know what's wrong with the car. I know what the car wants. I just can't find the fucking menu to make the goddamn change that I need to make that should take 30 seconds. And you have the customer sitting there staring at the goddamn camera into the dyno cell going, why is it running like that? Because, bro, I'm trying to remember where the software's at. That's why.
Yeah, and from the customer standpoint, because I mean, I literally just went through this. You know, I went to a good local tuner that has tuned SR20s, but he primarily does the V8 stuff. You know, carbureted, fuel injected, Ford, Chevys, all those. So, you know, I was like, hey, you know, you're local, you tune, you got the dyno. It'd be nice to build a decent relationship with him. And from a customer standpoint, choosing your tuner based off of what they tune, kind of it reflects on the quality of the tune and the turnaround time as well. So we showed up probably at 10 o'clock in the morning, and we left at 7 o'clock in the afternoon, and all we accomplished was the fuel map. And it literally just comes down to how long it takes them to go through those menus, find what they need to find, make the changes, make sure that that reflects in the tune, like they get the result that they can see. And if not, like they have to put that back and then go try to find another menu and start changing things. So we spent like 4 hours trying to figure out the CAN connection on the Link ECU. Couldn't find that out for the wideband. So we just hooked it up analog, boom, it worked. And then we started tuning towards the end of lunch. But yeah, as a customer, like you can't be mad at the tuner. Like you can't say, hey, this dude's a shit tuner, because you brought him something he's not familiar with and everything didn't get done in your first appointment.
Dude,
so
that goes to this. That goes to say the same as fucking going and buying eBay parts. Oh, let me go buy this eBay part and or these CV axles. I got a 900 horsepower Honda Civic. Let me go get these eBay axles and hope that they hold up. You go make one pass and snap an axle. I mean, look at what we're working with. You can't expect people, and personally in my shop and my customers that are watching this know that when you come to my shop, I will not let you order your own parts. If you are adamant about ordering your own parts and doing your own thing, I am not liable on the labor or the part, because that part's going to fail. So I always tell my customers, yes, you pay a little bit of a markup, but I still beat the list price. But I will not let you buy your own parts and install it and warranty it. I can't warranty an eBay part, right?
Well,
So that goes back to say, like, again, you want to put eBay axles on a 900 horsepower Honda Civic, they're not going to hold up. You're going to have to spend the money.
I think one of the biggest things that's being missed is, people will say, oh, this tuner is shit, this tuner is this, that. Well, did you bring the car there? And, most good tuners are going to have a checklist of everything you need to go over before you even put the car on the dyno. So you're not wasting your time and money. You're not wasting their time and money. And
a good tuner will have a checklist.
Because I know
we got some shade tree fucking tuners out here in North Carolina that will be like, yeah, man, we'll send it, we'll throw it on the dyno, we'll tune it for you, and if it blows up, oh well, it's your problem, not mine. You know what I mean? And
that's true. I'm not liable for your shitty build.
No tuner is truly liable,
bro. Like, and you want me to put it on the dyno and tune it? You got to have some checklists. You know what I mean? Like, is there rod knock? Is there, is there lifter tick? What have you done to the internals? You're putting a fucking turbo on it. Did you do anything to the internals, or is it all stock? You know what I mean?
Well, I'm not even talking about that aspect of it. I mean, did you come with an extra set of spark plugs? Did you change the spark plugs and coil packs before you even got there? Change the oil, make sure that nothing's leaking, everything's fucking plugged in right. Just stupid shit that people oversee because they're like, oh, as soon as I slap this engine back in the car and I can get it started, I can go straight to a tuner and be done. And they half-ass getting everything back together and then take it to the tuner, and then the tuner's like, well, I can't do anything with it because, I've got to fix all of this shit on my dyno and waste my time before I can even get to it.
One thing that Cody's bringing up.
Well, so just to circle back to the topic, because like that helps in troubleshooting. Like if you didn't check your hose clamps, if you didn't change your spark plugs, if you have loose wires that are shorting out, like these are things that present issues on the dyno while they're doing pulls that, if you make sure everything's good, you can narrow it down to, hey, it's a setting in the ECU, it's a gap in the plugs, let's just verify the fuel pressure or whatever. But if you've got loose lines, loose clamps, you're losing fuel pressure, you're losing boost through shitty couplers, you got wires grounding out. Like these are things that puts a tuner in a shitty position because he's just sitting there doing passes and making the adjustments, expecting his results to come out of the wideband sensor for him.
Or if you have to street tune, which it is what it is. But if you have dry rotted tires and you're trying to make all this horsepower, and then the tuner ends up blowing a tire out and wrecking your car, I mean,
been
that's
there,
on
done
you.
that.
Yeah, me and Seth went
Actually,
out
I've been
on
there,
the
done that.
expressway.
I had. Well,
I
we had
mean,
the fuel.
remember-
We had the cat clog. We had the cat clog on the Skyline, but I actually had a.
There was an
That was
FD,
a
was it not?
JCX. No, it was a
I thought it
JCX.
was
I think all the tires blew.
No, we did I think it was either S14 or an R33 that we took out. And the guy's like, big turbo, big injectors, let's let it eat. Seth and I take it out. I'm driving the car for him so he can do his thing. And, we get to the point where we're doing wide open runs, fourth, fifth gear type shit. And this dude's on like 215, 17 by 8J, like generic shitty wheels and tires. We're like, dude, how are you going to make essentially a 5.4, 500 horsepower car get tuned, street tuned, or you plan on running it like that? Like, we were blowing tires off, hitting boost in fourth gear.
So here's
I never heard somebody complain about blowing tires off.
There's a picture for you guys right there. So this is the current project in the shop right now. As many of you know, we had a lot of issues with the drift car, the shop drift car, and you can see why here. So we pulled the entire wiring harness out. For those of you that don't know, when a JDM car is imported to the Philippines, it has to be left-hand drive converted, which now you're not even technically legally allowed to import cars to the Philippines after Duterte changed the laws, which is what's causing me so much headache getting my RX-7 down here. But they do a left-hand drive conversion, right? So our R33 is left-hand drive. Not a big deal. However, they usually do some sort of race car style build, right? Aluminum dash, roll cage, being brought in for track use. And unfortunately, like most countries, it seems like this is the wiring you get. And everyone can obviously take a look. We've got the kill switch down there, which is improperly wired, by the way, to not cut the alternator power at all. The fuse box, some relays stapled to the wall back there. And when I tore all this out, which I got to the point where I just started cutting fucking wires, honestly. And I don't want to put the shop on blast because I know the guys and they're not bad dudes, but you get what you pay for, right? Especially with motorsport wiring. Motorsport wiring is not something that everybody can do. And there's a way to do it, and there's a way not to do it. Just because you can do wiring in a car doesn't mean that you can do wiring well, right? And there's a lot of people out there that don't understand when you wire a car from scratch. Earth grounding loops, for example. There were more grounding loops in this car than I've ever fucking seen in my life. And the issue with that becomes when, one, you're creating redundant paths back to ground, which can cause a lot of issues. Two, if your main grounding strap fails, say from the engine to the chassis or wherever your start point should be, which your start point should be the engine, right? Going back to the battery. All of those other tiny grounds now become the path back to the battery. And so instead of having a 2 all-wire gauge or a 0 all-wire gauge grounding strap, you end up with a 22 all-wire gauge grounding strap for your whole fucking chassis, and then it smokes the fuck out, right? And that's how you lose components. Some of the
For
things
those that don't know,
that
shit actually gets hot.
So what we actually found on this when I started tearing the engine harness apart and the chassis harness apart, because I don't like when cars don't run, especially cars that have my fucking name on the side of them, obviously. So I tend to go a little overboard and childish when I fix it. And I want to know why, more so as a tuner. So some of the things we found.
Stuff goes in and cuts everything out.
Some of the things we found in here, the alternator excitement circuit was not wired up to anything. So for those of you that don't know, a Nissan alternator will excite if you rev over 2,500 RPMs, I believe. I think it's like 2,500 or 3,000 RPMs. If you just blip your throttle above that, the alternator will excite and start putting out a charge current. I'll bet not the best or the right way to do it. The proper way to do it on your alternator, you obviously have the battery post, right, where it goes back down to your starter or to your battery. And then you have your 2-plug wire, right? Every alternator has like this 2-plug connector on it. One of those connectors goes to battery voltage, constant 12 volt. And the other goes through your dash to a light bulb that looks like a battery typically on your dash, and then back down to battery voltage. That light bulb acts as a resistor. And that resistance, when it detects that, when you turn your key over or when you start the car, tells the alternator to excite or to start generating the electromagnetic field, which then generates the power to your battery, right? Without that excitement circuit, the alternator does not come on. So you're running off of battery power only. So that explains why we had a parasitic draw on the Skyline. It wasn't a parasitic draw. Well, the fucking problem was. But it wasn't a parasitic draw. It was a fucking alternator that wasn't working. And that's why we were only getting randomly between 12.9 and 13.3 volts, because the alternator might come on. It might not come on as we excited it manually with our RPMs off the engine. But it was just a loose wire ran back. Same thing, the NVCS system or the variable cam system found on the RB25 had the circuit hooked up to the ECU to switch to ground to turn the cam on and off, right, to advance that timing on the variable valve. But it didn't have 12 volts. The 12 volt wire was just ran loose to the fucking air, not even hooked up. And what it shows is when whoever built this harness, well, I know who built the harness, but whoever did the conversion lacks a fundamental understanding of how these circuits work, right? And this is just 2 of about 53 things that I found just in the engine harness alone. I'm amazed the car ran it fucking all, to be honest with you. So we've now gutted this, and we are putting a Haltech PDM in it. We're going full PDM, which at this point you can get a PDM for $1,500, I think $1,600 for a basic PDM. And that's brand name. That's a Haltech. We sell Link also. I think the Link PDM is like $1,000, $1,200, something like that, through New Zealand direct. You can get Morris Tech, Black Box. There's a million different PDMs because they're just computer programmable solid state relays is really all they are. There is no reason in this day and age to have a fuse and relay board. Like back in the day, you saw the real fancy relay boards, right? The power distribution blocks and the fuses. There's no fucking reason for that shit anymore. You're going to spend as much money on wiring and relays and fuses as you are just going to a PDM. And now you can data log your circuits, right? And for everyone that doesn't know what a PDM looks like, wiring harness wise, you go from about 5 wires per circuit to one MOS wire. So it really is the best way to go. So circling back to the troubleshooting, right? Having that standalone, the same as Adrian, when we had the issues with the Skyline, because we had extra sensors put into the ECU with the fuel pressure and the fuel temp, we were able to quickly see that our fuel pressure was dropping off. And so, we talk about going in a system, right? Okay, why is the fuel pressure dropping off? You know your problem now. So understanding a fuel system circuit, right, or a ignition system circuit, start at the basics and you move through that circuit. So we have a pump that's supposed to be sending fucking fuel. We have lines, we have a filter, we have a regulator, and we have fucking the injectors, right? And then it all loops back into a loop circuit. So I knew the injectors were good because I just changed them to brand new injectors. We bypassed the fuel filter. We rewired the fuel pump directly to the ECU and the battery, eliminating the voltage drop. And what else did we do? Changed out the fuel pressure regulator, right? So we started eliminating these problems. And you need to have a systematic approach is the point. Like, okay, I'm going to change this. Did it fix it? No. Okay, I'm going to change this. Did it fix it? But if you don't have that, and a fuel pressure or a fuel system is a really good example because there's only like 3 components in the whole goddamn thing that actually matter, right? Your injectors, your pump, and your regulator. And that's if you don't have a deadhead system. So, but understanding and developing yourself a system that you follow is going to help you when you get to more complicated things like electrical issues like what Adrian had, right? I push a button, nothing's happening. Well, is the input actually changing? Is the voltage changing? Is the signal changing? And I think Adrian found an issue on his JZX actually, because despite us telling him the answer, he did his own troubleshooting with the multimeter where he literally pushed the button and the continuity didn't change. But if I remember right, when you had the multimeter hooked up between the switch and the digital input, it actually turned on, right?
Yeah. So whenever I put one contact on the pin for the AC request and touch the other to ground, it essentially acted like the switch and made it run.
Yeah. So you had, I don't know why that's,
Sorry, guys. Both my phones are going off, man. It's fucking nuts right now.
So
But to go back
in this,
to, go ahead, Seth.
Juan just jumped in and started talking. So in this case, I have no idea what's going on, but I'm going to say words. In this case, right, Adrian's multimeter was acting as the circuit. So that was a big clue that there was a wiring issue potentially, right? Or like I asked Adrian in the beginning, do you have a stock ECU? Like if you think the issue is something in the Link ECU, for example, because it's a common issue in Link, then put the stock ECU back in and see if the fucking circuit works.
Yeah.
Eliminate the problem, eliminate the variable. And that's what you're doing, is you're eliminating variables when you troubleshoot.
Yep. And it's always better to start with the simplest, least effort first step.
Yeah.
Don't go pulling, because I mean, I was literally about to do that. I was about to be like, hey, Seth, let's switch to a Haltech. Let's do the Nexus and get the PDM and let's do everything in one.
I still support that.
I do too.
Do that.
But I do too. But now it's like, hey, I don't have to do it this week to get the car running to start hitting events and shit. It's like, hey, I bought a house this week. I can do that later.
Right. Look at Juan working so hard, like a retard.
Dude, it's nonstop for me, and I'm getting ready to buy a tow truck, so that's going to be even worse.
Yeah.
I'm getting ready to buy a tow truck, so we're going to be, running county record. So, Cody, I've been meaning to ask you, what the fuck are you drinking?
This is the
Canto Ritos by Jaritos. Pineapple.
Yeah.
Pineapple.
So
are you in Georgia or Florida?
No, I'm still in North Carolina right now.
Oh, okay.
I picked this up.
He just doesn't want to hang out with you.
No, that's not the case at all. I ended up
What's new?
quitting my job this morning. I left a nice email and woke up to some phone calls from HR. So, but anyways, this honestly tastes like a chew high. This is the closest thing that you can get in the States without actually drinking one. 10 out of 10 would definitely drink it again. I'm going to try all the flavors now.
All right, Juan, say something interesting. I'm tired of being technical and educating.
Sorry, I was sending invoices out because people are commenting. So from a user standpoint, or as you were from a consumer standpoint, we talk about troubleshooting, and Seth has gotten into really big detail on what the Link ECU is showing, things of that, etc. If you're a DIY guy, if you are out there as a consumer, invest in a multimeter. It will save your life. It'll probably save you a few $100s on some shit that you could have done yourself that you ended up paying somebody for. So just keep that in mind, man. A multimeter will save your life. You can check relays, you can check resistancy, you can check continuity. If you have a break in a line, continuity is your best friend. You want to check end to end, etc., things of that sort. So just having a multimeter and knowing how to use it, there's plenty of YouTube videos out there. I'll post them on my website later on this evening, but there's plenty of YouTube videos out there on how to use a multimeter, how to check resistance, how to check relays with resistance and continuity, things of that sort. So like I said, we've all got, I won't say we've all, because I don't know what these other two guys have, but I know myself, Seth, we've got some high-tech scanners and things of that sort. I primarily do bikes, and even then, I went with the Solus Legend by Snap-on because it comes with, I had to purchase, It comes with the software, but I had to purchase the pigtail harness for motorcycles. But it'll do cars and motorcycles, and you pay an annual subscription, and I have everything unlocked to me, both 4-wheel and 2-wheel.
I don't have a scanner. I'm just smart.
Like I said, if you want to spend some money, that's a good way to spend money is on a scanner because mine set me back about $4,500. People even have a basic OBD2 scanner because most cars nowadays are OBD2. You won't see OBD1 unless you're working on something older.
So, with that
but
being
if you're
said,
using OBD2, it would behoove you to go out and purchase a scanner. You can get them on Amazon. You can get them on eBay. They have some pretty affordable scanners out there, but it'll kind of tell you where to start and what code you're throwing. There's a lot more to it. I know Seth is shaking his head, but there's a lot more to troubleshooting and diagnosing.
One was in the military.
Give you an idea of what's going on.
One was in the military for hours and drank all the words into his vocabulary.
So like you're talking to an engineer, dude.
I would say, if somebody that's at home, something simple, you don't need a $4,500 scanner from Snap-on that every year you have to update and pay. I don't even know what it is anymore. It's like $150 per manufacturer or something like that. Something like an Innova 5610. You can get the cable for it that is also OBD1, so you can run both, clear your own codes, check your own shit.
So I'm a big Snap-on guy, right? Like I love Snap-on, Cody, and you know that. But when it comes to scanners, man, a Launch X431V is literally all any of you need. Like even as a pro, they're like less than $1,000 on Amazon. They have two-way communication functionality. It'll do everything that Solus Legend will do. When it comes to scanners, man, I'm just not a huge fan of the Snap-on or the Mac. They're literally rebranded fucking Launches and Innovas and fucking O-Tools.
Well, so like my Innova, I actually got it on sale for like $150. The original price is like $350, but it does everything that I would ever need for it. I mean, I'm not getting.
So
at the high
okay.
I've got my Solus Legend, and I bought that specifically because it has access to all motorcycle brands. So that's the only reason I bought that. I'm a big Matco guy. I like Matco tools. I buy all Matco tools, and matter of fact, I traded in all my Snap-on tools for Matco.
That's because
our dealer here sucks, but. And I don't care if he roasts me for this. I don't give a shit. But our Snap-on dealers are trash. Matco dealer was the first one that said, "Hey, I'll come to your shop, no problem. I don't care if you're out of my way. I'll show up on Fridays at 12 o'clock." And he shows up like clockwork on Fridays at 12 o'clock, whether it's warranty tools for me to buy new tools, for him to update my shit. Does not matter. He shows up every time. So that's why ultimately I switched to Matco. And I had this conversation with these guys before. Everybody in the Fuckboy Squad originally. I spoke to these guys, and it's really came down to availability, who's willing to come out to you. So I switched to Matco for that reason. Now, with that being said, I have the Snap-on Solus Legend because Matco does not have a scanner with their name on it that does vehicles and motorcycles. Snap-on does. And Snap-on currently owns a contract for the tech that goes into Harley-Davidsons. Well, I purchased that as well. Again, it's 90% of what I do. I specialize in Harley-Davidson.
You muted yourself.
Yeah, he's a retard.
So having a system that goes into both automotive and motorcycle was very beneficial for me. However, for the first 3 years I was in business, I used an Innova. I got an Innova from Advanced Auto. It was originally like $430. I paid probably $250 for it. Got a basic scanner. It kind of tells me everything that I need to know. I can get live data readout, which is also really important. If you are not familiar with live data, get yourself familiar with it because you can have an evap code and try and track it down, not know what the fuck you're doing. But something simple as an Innova will tell you, hey, dummy, your O2 sensors are probably bad. you can pull up the live data and read out the percentage and voltage on your O2 sensors. So that's something that a basic scanner doesn't do, like a $20 scanner, because they do have them out there. 20, 30 bucks on Amazon, you can get you an OBD scanner that'll give you the P code. That's cool and all, but when you have something that gives you live data and you can read that live data, get on YouTube, learn about it, know how to read that shit. So when it comes down to diagnosing and troubleshooting, you can know, okay, it says I have an EVAP code, but according to this live data, my upstream O2 sensor is not reading.
Yeah. So,
or I'm running lean, or I'm running rich. It's not going to tell you. It's going to tell you rich bank, number 2. Well, you don't know what the fuck that means unless you read out. You could be rich, or you can be running lean, but your math could be the issue, and you won't know until you look at the live data and be able to look at the live data and say, okay, well, it says I have a math issue because I'm running lean, but when you look at the live data, it tells you, oh, well, your math is actually reading out fine. It's your upstream O2 sensor that's bad.
So, yeah, obviously. Yeah. He doesn't know how to use a background. So, one of the things Juan's saying and what he's also getting to, right, is data logs are amazing. Obviously there's a huge difference between what I do and what Juan does as we talk through troubleshooting, and obviously the way we take our approaches to it, because what I'm usually working with is performance-based cars versus Juan with his, generally factory spec or motorcycle spec cars, platforms. So data logs are great, but data logs can also lie. So, for example, the Haltech also has an OBD2, or what we call a DTC system, right? A fault system, where it'll throw the check engine light, and then it'll give you a P code essentially, and tell you why the check engine light's on. But what you have to realize is wideband going lean safety can also mean that you have a misfire, and it went lean because you had a misfire. Right. So you can't always take everything at face value when you're troubleshooting, because okay, you take off, you hit it, right? And I did this with the Ducati, actually, circling back to multimeters and how useful they are. We get up to about, say 4,000, 5,000 RPMs in the Skyline or in the Ducati, both of them are very similar. And you get the breakup, right? That inevitable where it feels like the engine just went on fucking jet lag or lag mode. And it throws a lean code for the wideband. Well, the fucking engine's not lean. It's actually rich as shit, right? But it's misfiring. And so it has that momentary point of lean. And so it throws the fault code, right? And so that's why when you do go to a tuner, or if you're going to try and program your own standalone ECU, and you're going to enable these advanced safeties, and with like a Haltech 2500, we have 3-dimensional safeties as well that we can set up. You need to understand how you're setting it up, right? Because you don't want to set it up to the point that it's so trigger happy, for lack of a better term, that it immediately throws a fault the first time that you have a lean condition, and then puts the car into limp home mode, because every time that you go into overrun, for example, or decel, you're going to go lean, right? It's designed to save fuel. Every car in the world has been doing that since like 1943, right? They figured out how to shut the carbs off when you came off throttle with mechanical linkages and shit. Like, that's literally the point, is to save gasoline. So it goes lean on purpose. And when you're cruising, right? So even if you're in 1,000 horsepower fucking Viper, when you're going down the highway at 3,500 RPMs, or fuck, I don't know, Viper 1,700 RPMs probably, and you're just cruising, right? With very little throttle input, there's really no load on the engine. You actually, as a tuner, when we tune that, I try and tune that as lean as possible, without letting the EGTs get out of control, because that's where your gas mileage comes in. And that's how you can have 1,000 horsepower car that actually gets better gas mileage, as long as it's got a boost in fucking power, than a Honda Civic. Because you're just trickling fuel into the engine to keep it running, is all you're doing. You don't actually have a load on the engine. Yeah, now once you push the throttle and use all that power that you've paid for, like, you're gonna watch your gas gauge move visibly, right, as you drink gasoline. I mean, you start dropping 2,000cc injectors in, right, or 200 pound an hour fucking injectors, like, fuel goes.
I'm not drinking alcohol. What are you talking about?
What? So going back to the multimeter, one of the functions that Juan didn't mention when you buy a multimeter, because you can go down to Home Depot or Lowe's or your regular hardware store, right, and get a cheap multimeter for 20, 30, 40 bucks. But getting something like a Fluke, right, and buy it once, cry once for 200 bucks for a proper Fluke, and make sure you're buying the correct Fluke, because they have specialized multimeters for every application. Computer network guys, car guys, fucking electricians, like they have different models of the Fluke. So make sure you're getting the functionality you want. But the diode test feature, right? Being able to test a flyback diode or test a diode is amazingly powerful. Yep, Arthur, I agree with you, actually, for the Snapple.
Dude, we ran into this issue with fucking
with the Ducati.
One of our race cars is a diode. You know, diodes. Anybody that rides a newer Harley, Milwaukee 8, diodes are a big issue, especially with the Milwaukee 8s. So that's going to be your 18 and a half, later 18 and a half, and newer bikes all have Milwaukee 8s, whether it's a 107, fucking 114, does not matter. You got a Milwaukee 8. They have diodes. The twin cams do not have diodes, so having the capability to check diodes and check the resistance on them, being able to test them in-house with the multimeter is very important.
All right, I'm going to share this as we close out the next 9 minutes. I like to circle back to things. So this is Evans Tuning. Evans owns Evans Performance Academy, or whatever it's called. I'm a subscriber to his site. If you have a basic understanding of EFI systems and how to generally tune or how tuning should work, Horsepower Academy is great, right? HPA, they're awesome for getting you an up and running knowledge, and some of their stuff is very dialed in. Their webinars are amazing. Honestly, I think HPA is better for their webinars than even their courses. But Evans Performance Academy is more of if you think of it in college terms, it's more of a 301, 401, right? It's more of your junior and senior year going into your graduate degree kind of thing. Gets very, very detailed and very, very like down to the gnat's ass of tuning. And so if you understand tuning and you're going to specialize in an ECU, like when I picked up Link, right? I took Evan's Link course because I have his VIP membership, so I can take any course I want. It's 153 fucking YouTube videos that he put together basically on Link, and it literally goes through every menu, every button, every fucking everything, right? The dude's really, really smart, but it is pretty advanced. And they have the same thing for Mtron, they have the same thing for Haltech, et cetera, et cetera. But this is his pre-dyno tuning checklist. So, it immediately starts out with electrical, right? No exposed wires on the engine harness. Solder or crimp, right? Never twist wires together. Guys, I can't tell you how many fucking wires I've found just twisted together with electrical tape wrapped around it. That is not how you fucking do something. Solder is slightly better than that. However, in a motorsport application, if you actually go for your certification, we always do an inline barrel crimp. We never do a solder, right? Because a crimp is actually stronger than solder, and solder will crack and fail over time. That's why we don't use it in professional motorsports. Making sure your alternator is working. That's a huge thing. Your alternator, your voltage output affects your injector pulse width, right? So that actually affects your fuel mapping. So if that's not stable and consistent, we're just going to be chasing our tails as a tuner. Fuel pressure, I'm going to go through and I'm going to check that for you before I put your car on the dyno anyway. And then we can typically tell, you get enough experience dialing in a fuel map, you can tell when the fuel pressure starts dropping off. And if that's the case, then we may put a fuel pressure sensor in line. I recommend everyone puts a fuel pressure sensor into their standalone if you don't have one. It's 2024. There's no reason for a mechanical gauge anymore. Just put a fucking sensor into your ECU. And then you can use it as a safety as well, right? Yep. So we also will do a compression test before we put a car on the dyno. We check the oil levels. Like Adrian was mentioning earlier, like there's people that show up literally with no oil in their fucking car. Adrian, toeing up a mountain. And then,
It ran.
depending for 35. So one of the things that we may or may not get into, right, and it really depends. For a street car, we're probably not going to get into it, but your valve lash, right? For a drag car, or if we know we're going to be chasing the high level powers, then we might actually pull your cam covers off and check your valve lash, which is the play right between your cam and your valves, or the free float, essentially, right? So we'll check that.
Also, rockers too, man. That's a big part. Rockers. Okay, when we talk about, I'm in America, obviously. So when we talk about, I've got a guy that brought me a three stroker. That's cool and all, man. I'm glad you spent the money to get the motor stroked out, get it built, and stuff like that. But when you got a stuck lifter and you got a stuck, your rocker's bad, rocker bearing is bad. Come on, man. I'm not going to tune a car or even drive it down a road with nasty lifter tap.
Yeah. So then, obviously, also getting into exhaust leaks, right? Which we have a smoke machine to test that. If you have an exhaust leak prior to your wideband, it's going to throw your AFR readings off. So we'll be tuning to correct, but it actually won't be. So that could cause issues with your engine. And then ignition, obviously changing your spark plugs, like Cody mentioned. When you go to a race application or performance spark plug, you have to let your engine come up to temperature. If you don't, then it'll foul the plugs quick as shit. As Adrian knows, because he had to come save me a couple times when my fucking 12 temp fucking race plugs fouled out on me on the RX-7 because I was stuck in traffic. So that sucked.
I mean, they're only $100 a pop, so.
Yeah, right. And then your plug gapping, you're making sure your ignition is actually working is good. Yeah.
Just carry the gauge on your keychain. Jesus Christ. They're 25 fucking cents.
Right. Make sure you actually tighten your wheel lug nuts.
Dude, I cannot stress that enough. You talked about fucking spark plug gap. I cannot stress that enough. I can't tell you. Okay, so for those guys that are watching, if you go to Harley Davidson and buy the Screaming Eagle plugs, which is what I recommend, because it's about the only thing that Screaming Eagle makes that's good. Okay, you go buy Screaming Eagle plugs. They still have to be gapped to your motor. Gap your fucking plugs, dude. I come up and for example, on a twin cam, you're supposed to have 35 mics on a fucking spark plug. If I pull your spark plug, it's fouled as shit, and you only got 20 mics on a fucking gap, that's not okay. Like, gap your spark plugs to what they're supposed to be per specification. You can go on Google and get your PDF version of your service manual, and it will tell you. You can probably Google, what is my gap on my 2007 Ultra Classic? It'll tell you your gap is 35 mics. You come back and you got 20 mics on it and your spark plug is fouled, well, there's the start of your problem.
Yeah.
So I think that's manufacturer, certain vehicles have been out for so long now that people have been trying different things. Base it off the best knowledge that you can find. Like the EcoBoost, I think the gap's supposed to be 35. Everybody says to run like 32. And since I've started doing that, I don't foul plugs out anymore personally.
Right? They tell you 35 to 40. You know what I mean? They give you a range.
We're wrapping up here.
They're notorious for that, giving you a range. Oh, it's supposed to be 35 to 40. When I work on a twin cam, it tells you on the Harley Davidson service manual, it tells you on a twin cam, 35 millimeters. That is your gap. Not more or less. I think you got like plus or minus 2 millimeters.
There's
35 millimeters.
So we're going to wrap it up. Appreciate everyone that did dial in. We had a pretty small audience this week. Instagram was down, so I wasn't able to stream to the Instagram, which sucks, but it happens. Join us next week, guys. We'll figure out what the fuck we're talking about again, I guess, or something. I don't know. We'll ramble on about shit. So, all right. Thanks for watching. Peace.